My friends, welcome to my channel. Today I want to discuss a Reddit post on FreeCAD. This is a newcomer request on FreeCAD Reddit. So the summary is this is a simple pad and the corner is filleted to the maximum. But the person wants to control the fillet profile a little bit more. The problem is fillet is always a circular profile and it is always limited by the height of the pad that we are talking about. But the original poster, they want to flatten it and cover more ground with this fillet. And my initial thought was we would have to do a custom fillet, which is draw this profile on the side and then kind of like make a revolution and cut it out, or like subtractive pipe would be one way to go. And that was the similar suggestion came around. However, at the end, this is what it comes down to, where so that custom fillet works, that the groove works, but the corner comes a little short. So the preference is the corner would be a little pronounced. It is also too much rounded now. And with that, I thought we would explore a few other avenues, and I recommended that. But I found out this would be the surface modeling would be our answer to this problem. So let's do the whole thing. Let's see how we can create a custom surface and convert that as a fillet customized to our needs. So I will build that model from ground up. I will draw a sketch. Actually, I will mix part and part design in this model. So I'll start with part design. I'll create a body, create a sketch, and this time it will be on XZ plane. So I'm trying to mimic what it is in there, and I will create a rectangular pad, something like this. So this is going to be, say, 15, and the height is going to be 10. Right. And then I want to make it symmetric. There. So this is our first pad. Let's say base sketch, and I want to pad it. So this was 15. So I want to pad it for 15 millimeter symmetrically. There. And now I want to groove out the middle part. So that would be another sketch on XZ plane, and I will turn on the cross section view. And here I want to draw this profile, something like this. So this is going to be approximate, not the exact thing, but it will be close. All right. So this height is going to be 5, the total half of the total height. Let's make this one horizontal. So select the edge H on the keyboard. That's horizontal. There. And then I want to make this point about 7 millimeter away from the center. And this inner profile would be 2.5. Okay, I think we'll just leave it there. Yeah, we'll just leave it there. That's not the big point. So here I want to groove it out. Ooh, I didn't want the middle part to stay there. So what I will have to do is actually take this 2.5 out and make them coincident, these two. There, that will do. So that kind of matches our object. And now, so this is 15 millimeter, and I want to draw the fillet around. So where traditional fillet is subtractive, I want to draw it as an additive feature. So what I will do is, actually I want to keep it as a separate part. So it would be a different body. Tell you what, let's switch over to part workbench. As I said, I want to switch it up because everybody keeps telling us, like I also told everybody, like if you are a beginner, don't mix part and part design, but at some point you will have to mix part and part design to be more proficient in FreeCAD. So let's do that. I want to draw another sketch on part workbench, this time on XZ plane, maybe YZ plane. All right, on this one I want to draw that on this side, on the left side. So I want to pull in this geometry. I am using FreeCAD 1.1 developers version. I say that because this external geometry is different between FreeCAD 1.1 and the stable 1.0.1 version. In here, the external geometry will pull in construction geometry if you have it construction. For this case, it will pull in the solid geometry. So I want to transfer it to construction and pull in this point. So this is the intersection geometry. It will only bring in a point of the edge that's intersecting the face that we are building on. All right, so we got that point. Now what I want to do is I want to draw an arc. It would be 3-point arc. So take it from here and bring it over here and something like this. Now this one I want to go something like this, so like far wide than that. So this is going to be more than 10. This lower leg, the upper leg is 10. And to do that, to make it tangential on top, I will take this center and the upper edge of the arc and make them vertical, V on the keyboard. Right? So now I have my custom fillet. I will make it exaggerated, so a little big, so we can see the difference. And let's say this is actually, without going to the radius, I want to fix it with the distance. So let's make it 25. Right. So that's the profile of the fillet that I want to build. I want to close it up. Make this vertical, and that's a fully constrained sketch. And what I want to do is now I want to, so this is the sketch fillet profile. Now I want to extrude that. So this is 15 millimeters. I want to extrude that for 15 symmetric. So far we have built a body in part design, another body in part workbench, and now we haven't still mixed anything up. So we are just building separate bodies on the tree. At this point, no mixing up. All right. So we got this. Now we'll have to worry about this corner. So before I go to the corner, let me show you my work plan. I want to take this extrude and array it 4 times with the center being at the middle. And so this is going to be my filleted end, and now all I have to do is build this corner and then array it one more time. Delete it for now, keep this one, and then we'll array both of them all together, one array. So now I want to do a corner. To do that, we would go with surface modeling. So far we have been doing 3D modeling of solid modeling. I will switch over to surface modeling. So I will go to the surface workbench and do the surface. Before to do that, I'll have to actually draw a sketch at the bottom and another one at the corner. So let's do a sketch on XY plane. In here, so this was 25 millimeter away. So that means we need to do a square, round rectangle, something like this. Let's say the corner is 5 millimeter for now, very sharp corner. And I want to make it symmetric. So take these 2 corners and make it symmetric by the origin S, right? And then these 2 edges will be equal because it's a square that we started working off. The distance between these 2, actually, why are we building the whole thing? I want this only corner. something like this. And let's do that. We want to have this distance 15 by 15, or like 7.5 rather. So I'll take a rectangle like a and make it construction geometry and draw a rectangle right there. And now I want to make these two equal, and one of them will be 15/2 there. So that's the point fixed there. And now we have 2 degrees of freedom, so these two obviously is going to be equal, right? And now 1 degrees of freedom, this is going to be how much? So this point is going to be 25 millimeter from the center. That's an easy calculation. All right, so we have the base. We needed this because we want this corner, right? Now let's see. Now I want to have, maybe I need this array right now. I wanted to do it later, so I'll just do it now. So rename that as fillet side, and I want to array it. I'm using draft array. I have that shortcut on my toolbar, but go to draft, and in the array, polar array, that's what we want. All right, in here we want 4 pieces, and the center of rotation would be at the 0, and hit OK. I want to fuse it, obviously. There. So we need that because we need the support edge. Okay, we got the array. Now here what I want to do, I want to go to surface and make a surface using these 3. So it would be a filling surface, and I want to add this edge, this edge. Okay, but there is an issue. I can see that because it's a polar array, selecting one edge, selecting all of them. So let's go back. Tell you what, I'll take this array, go to part workbench, and make it a fusion. Let's see if that solves our issue. Now filling surface, so take this edge. Okay, so fusion was like converting that to a solid, so that worked. Take this and go from here onto, somehow the surface is not working fine. The filling surface, the boundary edges, it's not working fine. I don't know why. I'll try another thing. I'll just take all of these and go to curves workbench and make it a join curve. So that's one way to convert this edge as one edge, say one B-spline. Now let's see if that made any difference. I want to select that edge, take this and take that. All right, it's kind of not working fine. That surface is not, so let's hide this. Yeah, that surface is not working fine. Okay, let's see if we can. So I want to create an edge guide in the middle. So select that edge and go to create a datum plane. You can see that it is at horizontal level. We want to make it vertical. So I want to rotate it 90 degrees by Z. Didn't work. So here, all right, there. So X 90 degree worked. This uses local system and it always confuses me, so I just like give trial and error. And now I want to rotate it so it aligns this corner. So let's make it, say, that would be 45. Nope, not that one. Maybe here. There. Okay. So we got that. Now on this datum plane, I want to draw a sketch. And I want to come from here to there. So this is going to be, we need to get external intersection geometry. So we get this point, right? And now I want to draw an arc. All right, so this arc, we cannot control the curvature. It kind of like by default comes. All right, now I want to give this one another try. I want to go to surface workbench and create a filling surface. Take this edge, this one, and this. Right, and then I want to make it edge constraint. Add this edge as my constraint. All right, I think that edge constraint helps. So before it was too uncertain for the software to go where to build the surface. Now that we have an edge constraint in the middle, like guide edge, the surface looks fine to me. So hit OK. All right, there it is. So to have a more defined profile, I see why this edge constraint is very helpful. So now we have this curved surface, but we'll have to make it a solid, so the whole thing can be a solid. So what I want to do is I want to keep that surface right there, right? And I want to build surfaces all around. First, I want to go to, actually I'll stay in surface workbench and start filling in this lower surface. I can do that in part workbench as well, by the way, in the shape builder. Okay, and now let's bring our original surface back, and we can do a linear connection in here. So go to part workbench, take these two edges. Actually, I'll just go ahead and do the surface filling. So take this edge, and take this edge. There. We will do the same on here. Take this edge, there and there. Okay. So we have the whole thing closed off. Now we'll have to, so this is still a shell. Without like going into deep, this one and this one look exactly the same to me from this, but I can say this is a solid. This whole area is a shell because I built it in part and part design. The extruder pad always makes it a solid. The software knows that's a solid part. I build these as cover surfaces, so this is still shell. So what I want to do, I want to select all these 4 surfaces, right, and go to curves workbench. We used curve workbench a minute ago as well. This is an add-on workbench. If you haven't installed it, you'd have to go to toolbar, the tools, and add-on manager, and search for curves workbench, and then you can install it right here and then restart the software. So in curves workbench, there is this button, it says parametric solid. So select all the surfaces and hit parametric solid. As soon as I hit it, it will be a test for me if I build this right. So okay, now you can see, all right, there is a surface visible. I'd hide that. Now you can see the color of this solid is the same color as how it appears on the toolbar. That means that it is a solid. If it came in as like a grayish, like black instead of green, that means the solid did not form right. So there is one test right away. So looks like this solid is actually a solid. Even if you are not satisfied with that, there is another way we can check it. Let's see if it performs well. So select on the solid, go to part workbench and check geometry. Always keep this checked on, run boolean operation check and run check. Oh, looks like it is failing. Okay, let's see what is the error. Invalid carbon surface. All right, so the icon says it is working, it is parametric, but the boolean operation check says it's not solid. So we will see how that affects us. I want to keep continuing on this. So now we have one corner and we have 4 other in middle edges. I will take this one corner and mirror that, array it for 4 times, keep the center of rotation at the origin and hit OK. Now if you are building a rectangular profile, so to speak, instead of this square, the array probably will not work. You would have to go to lattice to do the array, like the proper custom placed array, or just copy and paste it, or like clone them and then manually place them around. So now we have this solid, these 4 middle parts are solid, and these 4 corner pieces are solid. What we want to do is we want to take all of them, this one, the middle fusion and the middle body. At this moment, so far we have worked on both part and part design, but at this moment we are working on mixing both part and part design. What I mean by that is I want to expand this on the tray. All right, now select the middle part that we built in part design. You can see that it selected the groove, not the body, right? So if you select it from the 3D surface, this 3D view, it will select the feature inside. However, the solid, the solid that was built in part design is actually the body is the solid, not the groove. So if you select it from the 3D view, it will select the feature inside. You would have to select it from the tree view, not the 3D view. Select the body to mix it up with other part workbench bodies. So this is a solid, this is a solid, the groove is not a solid, body is the solid. So select the body, select fusion, select array, and put all of them together as a union from part workbench. And I have refine turned off by default. I'm going to go ahead and turn it on. I didn't do much help, but so there it is. That is our custom fillet, which is a little wide. We can control the curvature of the main fillet, and we can also control the corner of the fillet. And I want to do a final boolean operation check, and it's still failing. It's failing the boolean operation check. There are a lot of discussion on this BOP check, and most of the times we want to pass it in the check geometry. This model failed probably because the surface, this corner, was not formed accurately. I want to do another check. If that passes, we'll be okay. If that fails, I still have to investigate more on this method, but let's see. I want to bring in a sphere somewhere. I'm gonna say there. And then I want to make a cut. So the cut worked. So the Boolean operation worked fine on this final model. So I'm gonna say, and there was actually discussion on this recently on the forum, the BOP sometimes fails where there are continuity, C0 continuity on surfaces that we build. So maybe it's a false negative or something. The check that we did on Boolean operation probably did not do a good job on this model, because the cut worked, and that's the ultimate test that we want to do. So with that, I'm going to say, but still always check geometry on your model if you are doing export in 3D model format. It works 99% of the time. This instance is the 1% where it actually the model is working fine, but the Boolean operation didn't say so. All right, my folks, that's how you create a custom fillet the long way, but you have full control on all this curvature on the side, on the corner, all of the whole area. So it's a full control system. It's a little longer way, but if that's what you need, that's what you need to do. Thank you for watching. If you have any question, comment or suggestion on this, let me know in the comment section below.